Professor César Camacho, Director of IMPA, Professor Hilário Alencar, President of the Brazilian Society of Mathematics, Rui Togero, and Luiz Florit to take place in the table. This is the open ceremony of the Differential Symposium on Differential Geometry, International Symposium on Differential Geometry, in honor of Marcos Dajczer. When a friend of us completes 6 birthdays, it's a very pleasure because it gives us an excuse to make a good conference and also have some fun enjoying with him. So the ceremony is, there is some fun and some parts of the work of Marcos, and we'll begin just passing the words to Luiz Florit, that is going to talk in the name of the organizing committee.
Hi, I would like to say welcome to all of you, and thank you very much for coming here. It's a great pleasure to have you all here. We are here to celebrate the birthday of my friend, colleague, and professor, Marcos. I am not going to talk anything about his mathematical career. That will be done by someone much more competent than me for that. But I just want to tell Marcos that it has been a huge pleasure to share with you all these years, and I have learned lots from you, not only mathematically. So it has been a great pleasure. So we have here lots of Marcos friends and friends from the house also. And some of them could not come from different reasons, but all of them send you big hugs and best wishes. But in particular, there is one person that Marcos is missing a lot, and we all miss also a lot. A special person and close friend from Marcos that is not here, that is Deter Filomol. I am sure he would have come if he could. So I would like to say thanks to all the participants, and especially to the speakers that prepare such wonderful talks. Also to the organizing and scientific committee that helped so much in building this conference. In particular, to Wolfgang Ziller, that worked a lot to bring here lots of NSF people, American people, that he won an NSF grant to support several Americans to come here. So thank you, Wolfgang, especially. And also Valsi, that always worked so hard to make a conference. A conference is without Valsi won't be a conference. So thank you. And another special thanks to the secretaries that worked so hard to make any single conference here. Someone has to work, and they are the ones that really work hard. So thanks to the secretaries. And the financial agencies, so it's CNPq, CAPES, FAPERJ, the Millennium Institute, the FAPESP also, and again NSF with the grant that Wolfgang won. Just my last word, please enjoy the city. If weather permits, on Wednesday afternoon, go out and enjoy this beautiful city. And the ones that will stay a bit longer also, enjoy the city as much as you can. Thank you.
As always in a birthday party, someone has to talk about the person that we are going to homenageate. We choose Rui Togero to do this work, and we now take the words.
Well, here I am again.
It's again the same conference.
Well, when I was asked to say a few words about Marcos and his work at this opening ceremony, my first reaction was to be terrified. I'm definitely not good for such things. But I must admit, after some time, I was really enjoying the idea. Well, we now all know the year Marcos was born. About his nationality, however, there is always some discussion from time to time. Anyway, he has now triple citizenship from Uruguay, Argentina, and Brazil. He makes no efforts to hide his preference for Uruguay's national soccer team, which may indicate which one he puts on top position in his heart. But this also explains why he had to look for happiness in something else. The first of such things actually is divided into three parts. The second one he uses to practice, even very far away. I guess that mathematics is the third one. Well, Marcos got his PhD in 1980 at IMPA under the supervision of Manfredo do Carmo. The main theorem of his thesis on reduction of codimension of isometric emergence into space forms has become a popular result among specialists in submanifold theory. It gives necessary and sufficient conditions for a submanifold to reduce codimension, that is, to be contained in a totally geodesic submanifold of the ambient space. To the young people in this room, the two pictures that I'm going to show to you now by him at that time may give you an idea of what 29 years of mathematics can do to someone. And I'll try to figure out who is who in this picture.
I quit. I quit.
Well, MathSciNet provides us a glance at his mathematical achievements since that time, at least as far as numbers are concerned. And I'm very proud that my name appears in large letters in his extensive list of collaborators. And this shows that making friends has always been an important part of his fun in doing mathematics. A few years after getting his PhD, he started to work on the subject that I would dare to say is his favorite research topic: the isometric and conformal deformation problem for submanifolds of space forms and rigidity aspects of submanifolds. His contributions, however, range on a wide list of other topics in submanifold theory. And these include the study of several particular classes of interesting submanifolds like real-Kähler, conformally flat, ruled, minimal, austere, and DuPont submanifolds, but also go into different topics like transformations of submanifolds, and more recently on superconformal surfaces and Dirichlet-type problems for constant and prescribed mean curvature surfaces in very general ambient spaces. In order to mention a few of his most important contributions, I have to make difficult choices. But these may be suggested by looking at the 5 papers that Marcos himself has selected on his latest CV as his most significant ones. 3 of them have arisen from his fruitful collaboration with Detlef Grumol, with whom he has written 9 papers from 1985 to 1997. Detlef would certainly be among us tonight had he not unexpectedly passed away 2 years ago. Marcos went to Stony Brook for the first time for a 2-year period starting in 1982. Initially, he was supposed to work with Blaine Lawson, but since Blaine happened to spend most of the time somewhere else, he asked Detlef to take care of Marcos in his place. And Detlef took this request so seriously that at least once a week he would listen to Marcos' report on how was he doing with his research and eventually on how much had he lost in his last bet on horse races. After a few of those meetings, Detlef would say, "Isn't it true that local differential geometry can be quite interesting?" But in spite of this, most of their joint work were nice results of a global nature. This was how they started a collaboration and, above all, a friendship that would take Marcos to Stony Brook for at least 6 more times later, including a period of 1 more year already in 1986 as a Guggenheim Fellow. And this would make a total period of about 5 years. And here is how they usually finished their working sessions. But what's much lesser known is that they have always had an important anonymous collaborator. Well, I guess I should say something about mathematics here. So the first joint paper with Detlef that Marcos has selected was on the problem of investigating to what extent are the induced metric and the Gauss map sufficient to determine a submanifold in Euclidean space. In other words, what are all pairs of isometric immersions of a given Riemannian manifold into Euclidean space that have the same Gauss map? Roughly speaking, they proved that locally the only examples are products of minimal real-Kähler submanifolds, which admit associated family just like minimal surfaces in Euclidean 3 space. But they have also been able to take care of some delicate phenomena of a global nature that may arise. So they actually proved that the family of non-congruent isometric immersions with the same Gauss map of a given isometric immersion is parametrized by a certain compact abelian group, and they have been able to completely determine the structure of this group. Well, the crucial property of minimal real-Kähler submanifolds that make them come in associated families is what they called circularity. But that any minimal real Kähler submanifold is circular has actually been proved only shortly after in a joint paper with Lúcio Rodrigues, who was another of Marcos' main collaborators, and his colleague at IMPA. And regarding the theorem of Marcos and Detlef, I should also mention that we have recently been able to extend it to the case of conformal immersions. And this may be regarded as a general version of a classical theorem by Christoffel for surfaces in Euclidean 3 space. And this also generalizes previous work of Marcos with Enaldo Vergasta, who had solved the problem for hypersurfaces. By the way, Enaldo was Marcos' first PhD student and completed his thesis in 1986. Well, in their second main paper, they studied complete minimal real Kähler submanifolds with codimension 2. In codimension 1, minimal real Kähler submanifolds had already been completely classified by them in another paper, where they proved that any such hypersurface can be locally parametrized by means of the Gauss parametrization in terms of pseudo-holomorphic surfaces in the sphere. But complete examples must be products of minimal surfaces and Euclidean factors of even dimension. In fact, in this stated in this way, this has only been proved by Luiz and Fang and Zheng quite recently. They had to assume that the hypersurface is free of flat points. In the codimension 2 case, they proved that irreducible complete minimal real Kähler submanifolds of dimension at least 3 are essentially holomorphic vector bundles over Riemann surfaces. And they can be explicitly parametrized in terms of a Weierstrass type parametrization. In particular, they have been able to construct many complete examples. Well, the third main paper with Detlef contains one of the few global rigidity results available for Euclidean submanifolds of codimension greater than 1. It's a version for compact Euclidean submanifolds of codimension 2 of a classical rigidity theorem for hypersurfaces due to Sachs-Steller. Roughly speaking, it says that every isometric deformation of a compact Euclidean submanifold with codimension 2 is, at least on connected components of an open dense subset, induced by an isometric deformation of a possibly singular deformable hypersurface that contains it. And as a consequence of this result, they have been able to answer a conjecture by Gromov on the relationship between the topology of a submanifold and its rigidity properties. Namely, they proved that an isometric immersion with codimension 2 into Euclidean space of a compact Riemannian manifold is always globally rigid as soon as the square of its first Pontryagin eigenclass does not vanish. Among Marcos' 5 selected papers is also one with Manfredo on conformal rigidity of submanifolds. It contains a generalization to submanifolds with codimension at most 4 of a conformal rigidity theorem of Cartan, about which I have talked on my talk this afternoon. And as I have talked in my talk this afternoon, the restriction on the codimension was due to a lemma on flat bilinear forms, which is a nice example of how linear algebra can get interesting. And flat bilinear forms have been introduced by John Moore as an extension of Cartan theory of exteriorly orthogonal forms, and has proven to be a useful tool in the study of rigidity properties of submanifolds. And Marcos has played a leadership role in its development. He conjectured for some time that the lemma should hold without that unpleasant condition, but that the conjecture was false was only proved very recently in another joint paper with Luis Floridi, who was Marcos' third PhD student. The last one of Marcos' 5 selected papers is a joint work with Manfredo and Franco Mercuri, where they completely described conformally flat, compact conformally flat hypersurfaces of a conformally flat space with dimension at least 4. Diffeomorphically, they proved that a compact conformally flat hypersurface is a sphere with as many handles attached as its first Betti number. Geometrically, the hypersurface is made up by possibly infinitely many non-umbilic hypersurfaces that are foliated by complete round n-1 spheres and are joined together through their boundaries to either an open piece of a nanosphere or n-plane, or a round n-1 plane, or a point. Well, this picture shows you a typical example of a compact conformally flat hypersurface with dimension at least 4. So as a first step of independent interest, they have been able to provide a complete parametrization of all conformally flat hypersurfaces with dimension at least 4, which are free of umbilic points. And then this was combined with a technique called conformal surgery in order to obtain the global result. Well, my collaboration with Marcos started in the late 80s. Well, I'm getting old also. So our first joint paper was completed before I had finished my thesis. And it was on that problem of understanding isometric deformations of a piece of a round sphere in Euclidean space, which I have already discussed in my talk this afternoon. I won't bother you anymore with that. But I should say that collaborating with Marcos along all these years has been a nice experience. Marcos has a sharp intuition about what's worth trying and what is not, so that if you come up with you can always trust him if you come up with some crazy project and he just says, forget about it. He knows very well how to push you to give your best and how to make you think you are doing something worthwhile. He works really hard when he's supposed to. And I can't remember a single email message that I have sent to him and he has not replied. And this may mean dozens in a single day. But above all, he has always been a best friend. Well, in the past 5 years, Marcos has considerably shifted his research interests. A significant part of his recent research has been on a completely different area, namely on Dirichlet type problems for constant and prescribed mean curvature surfaces in general ambient spaces. And his discipline in doing mathematics is very well illustrated by the origins of his interest in this subject. Some time ago, his mother lived in Porto Alegre, and after she got ill, he used to visit her quite often. Well, he thought, I have to figure out some joint project with Jaime Ripoll. Otherwise, I won't be able to pay for all those visits. And since by that time they were working on quite different subjects, they had to make a choice on who would have to start from the basics of the other's research topic. Well, doing this after you get your PhD and go for a postdoc is not very impressive. But after 55, it's not that usual. And it was about that time that whenever I visited IMPA, I would see Gilbert Trudinger's book on Marcos' desk, and in the beginning, open at the very first pages. And I was impressed on how fast they came up with their first joint paper. Well, Marcos' mother, unfortunately, died a couple of years later, but from the first 2005 paper with Jaime until now, he has written, as far as I know, at least 10 papers on that subject, with 4 distinct collaborators, besides Jaime: Luis Elias, Harold Rosenberg, Jorge Herbert Lira, and Pedro Hinojosa. Quite recently, he confessed to me, for many times I have listened to people talking about the Perron's method, the continuity method, a priori estimates, and the maximum principle, and so on, and I would never imagine that someday I would work on those subjects myself. Anyway, Marcos has always been open to new experiences. I forgot to... Okay, this is... Although he's not always very successful. Well, I know that these few words about Marcos have already become overlong, but before I finish, I'd like to make a few last remarks. First, I apologize for any important omission on either Marcos' collaborators or contributions. I had no intention of being exhaustive here. Second, I will ask the organizers to make these comments available at the conference webpage so that you may finally be able to understand what I have been trying to say here with this terrible accent from Minas Gerais. And finally, let me remind you that Marcos takes very good care of his health. The same discipline he has in doing mathematics makes him very well adapted to this fat-free and sugar-free business. So we will certainly get together every 10 years or many more times in the future to celebrate another of his anniversaries. So thank you and see you then.
Thank you, Rui, for this speech. Marquinhos, as we call, is a very deep friend, and I think his exposition tells us about him a little exactly what we think. The next speaker, the next talk will be from Hilaria Alencar, that's the president of Brazilian Mathematical Society.
Bom, vou falar em português mesmo. E eu gostaria só que, Marcos, estamos muito felizes de verem aqui muitos colegas participantes, e isso demonstra, né, o seu prestígio do ponto de vista científico. Então, quero, em nome da SBM, dar os parabéns a você e aos presentes. Obrigado.
I'll pass the word to Professor César Camacho, Director of IMPA.
Thank you, Balsim. I would like to welcome all the participants in this meeting in homage of Marcos on the occasion of his 60th birthday. Marcos, where is Marcos? Marcos is an outstanding member of the Brazilian scientific community that came from abroad in order to follow graduate studies, and here planted roots and developed his entire career. The remarkable progress achieved by Brazil in science in the last 50 years counted with the important contribution of foreign professionals like him that here found propitious conditions to develop their work. In a recent report issued by CNPq, our National Research Council, we can find interesting data that give a clear idea of the dimension of this foreign contribution. The so-called groups of research congregating the best scientists in the country were mapped in all areas of science, and therefore it is possible to measure the foreign participation in Brazilian science. The country that contributes most to Brazilian science is Argentina, with 400 scientists and engineers in the research groups. The second is Peru, with 285 scientists. And then come Germany, France, Portugal, etc., arriving to Uruguay with 100 scientists in Brazil. One never knows whether Marcos is Argentinian or is Uruguayan. So either he is in the first group or in the 100 scientists from Uruguay. This is clearly a consequence of the open policy of Brazil for science that in particular offers master and doctoral fellowships by the thousands to the best students independently of their nationality. A natural strategy of a country whose history was built over a strong basis of immigrants from several parts of the world. This is clearly reflected at IMPA, where about half of our students are foreign, mainly from countries of Latin America. Half of them return to their countries of origin. Marcos was an exceptional case. He came to IMPA as a doctoral student in 1977 with an impressive letter of recommendation by the distinguished Argentinian mathematician Calderón. He completed his doctoral course brilliantly under the guidance of Manfredo do Carmo in a period of 3 years and was naturally incorporated to our scientific staff. As a professional researcher, Marcos distinguishes by the vast and prolific scientific production with which he gained the respect of the international mathematical community, here represented by so many important mathematicians. As a colleague, he has been always concerned, and I would say also involved, with the academic decisions of the Institute, keeping a clear independence of his points of view, which naturally gives more value to his opinions. I would like to finish then wishing to all of you a nice and productive week at IMPA, and especially to Marcos a happy birthday and a warm welcome to the club. Thank you.
I would like to finish this opening ceremony inviting everybody to a cocktail that was serving in the lounge. Thank you very much.